The CPU is the brain of a computer. It's a tiny chip that dictates everything your computer does. From simple tasks like opening a file to complex calculations, the CPU handles it all. Without a CPU, your computer would be nothing more than a lifeless box. It's the engine that drives every operation, no matter how big or small. Understanding how a CPU works can seem daunting, but it's actually quite fascinating. At the heart of the CPU lies the data path. Think of it as a superhighway inside the chip. Data, like cars, travels along this highway, moving from one part of the CPU to another. Just like a highway needs on-ramps and off-ramps, the data path has different components that control the flow of information. These components include registers, which temporarily store data, and the arithmetic logic unit, which performs calculations. The control unit acts as the traffic cop, directing the flow of data along the data path, ensuring everything runs smoothly. The speed at which data travels along the data path, known as the clock speed, directly impacts CPU performance. A faster clock speed means more instructions can be executed per second, leading to a faster and more responsive computer. However, just like a highway can get congested with too many cars, the data path can become a bottleneck if it's not designed efficiently. The number of lanes on the highway, or the width of the data path, also plays a crucial role in performance. A wider data path allows for more information to travel simultaneously, increasing overall throughput. Ultimately, the design and efficiency of the data path are critical factors in determining CPU performance. Section 4. From code to action, a three-step journey. But how does the CPU actually process instructions? It all boils down to a three-step cycle: fetch, decode, and execute. First, the CPU fetches the instruction from memory, bringing it into the control unit. Think of this as the CPU reading a line of code. Next, the control unit decodes the instruction, figuring out what needs to be done. It's like understanding the meaning behind the words in that line of code. Finally, the CPU executes the instruction, performing the necessary operation, whether it's adding numbers, moving data, or comparing values. This fetch, decode, execute cycle is the essence of how a CPU works. It continuously repeats this cycle, processing billions of instructions per second, bringing your digital world to life. The CPU's data path is like a microscopic highway, bustling with information. Understanding its components and how they interact is key to grasping the power and complexity of modern computing. From the clock speed to the width of the data path, every detail matters. Remember the fetch, decode, execute cycle, the fundamental process that drives every action your computer takes. It's a testament to human ingenuity, a testament to our ability to create machines that can process information with astonishing speed and precision.